Lab experiment number 1, titled Determination of Chemical Formula, was conducted in order to enhance the students' practical application of concepts learned in class lectures. These key concepts are the mole concept, stoichiometry, percentage composition, and empirical and molecular formula. The experiment revolves around finding the formula of an unknown hydrated compound, which has the general formula of Cu subscript X, Cl subscript Y, times Z H2O, where X, Y, and Z are the integer values that we are looking for in order to determine the formula.
The procedure the experiment followed was to obtain the mass values of copper, chlorine, and water after separating the three through a different separation technique. This involved the following steps: weighing the crucible, then weighing the crucible with the sample, evaporating the water from the compound and weighing it again, transferring the contents to a beaker, then adding water and an aluminum plate to react with the solution to become colorless, measuring the weight of the filtering paper, then using the filtering paper to filter the copper from the rest of the solution, then weighing it, and drying the copper content on the filter paper inside a dry oven again. All of these steps were to get the mass data points of the copper, chlorine, and water after separating these elements and compounds from the initial state of the unknown compound. We can analyze the data and apply calculations to solve for the mole ratio of the distinct substances. This is a table showing all of the mass data values from the experiment. With these, the process of solving for the empirical formula can begin. The first step is to find the percentage composition of the unknown compound. After this, a 1 gram sample was assumed and moles of each element were computed. Once the moles of copper and chlorine, respectively, were computed, they were both divided by the smaller mole value, then multiplied until whole. This resulted in an empirical formula of Cu2Cl9 from the actual data of the experiment. Calculate is the number of moles of H2O in the formula. To do this, convert grams of H2O from the experiment into moles, then use the mole ratio of H2O to copper in order to obtain the final formula of the unknown compound based on the actual date of the experiment, which is Cu2Cl9 plus 5.29 H2O.
However, the formula calculated is not the actual formula of the unknown compound, that is copper chloride hydrate, which has a different proper chemical formula. This means that the data was collected from performing the experiment was not fully accurate, and processes went wrong in certain stages of the procedure. In order to find the correct and proper empirical formula, the ideal values instead of the actual values for the experiment were used in obtaining the copper chloride compound with a chemical formula of CuCl2 plus 2H2O. These came from a similar experiment tested by Michigan State University, who have more detailed and accurate weight readings, thus reducing the chances of inaccuracy. With the values they obtained from the same experiment, which is in this table here, the same process of solving was used. After doing the calculations, the proper empirical formula of copper chloride hydrate
The process of attaining the chemical formula can be applied to pharmaceutical or chemical engineering courses, wherein various chemicals are incorporated to create a solution for health, environmental, and agricultural benefits.
During processes such as filtering and drying, our group may have erred in ways such as not transferring all of the solutions and content, adding too little or too much water in different steps, and leaving the filter paper and its contents in the dry oven for too long.
These are the potential causes as to why our determined formula was incorrect, as it traces back to the data, and eventually back to the improper execution of the procedures done to get the data values.
In order to improve our performances in future experiments, we can be sure to perform the procedures and processes more meticulously so that the chances of human error making data incorrect would be minimized. The ability to learn from mistakes and errors is important not only in science, but in life as well.